Have you ever stood beneath a sky still heavy with the scent of rain and witnessed a miracle painted across the clouds? A magnificent arch of color, so vibrant and fleeting, it feels like a secret whispered by the heavens. This is the rainbow, a spectacle of light and water that has captivated humanity for millennia. But what is this magical arc, and how is it born from a simple rain shower? Today, we journey into the heart of a raindrop to uncover the science behind one of nature's most beautiful phenomena. It's a story not of magic, but of physics so elegant, it feels like poetry. Imagine the world just after a storm. The air is clean, washed fresh by the rain. The sun, emerging from behind the clouds, casts its golden rays across the landscape. Millions upon millions of tiny spherical raindrops still linger in the atmosphere, suspended like a vast curtain of microscopic jewels. These are the canvases for our celestial masterpiece. Our story begins with a single ray of sunlight. What we perceive as white or yellowish light from the sun is actually a composite, a hidden spectrum of all the colors we can see. Leads. It's a jumble of red, orange, yellow, green, blue, indigo, and violet, all traveling together in a straight line. Now, as this sunbeam strikes a single, suspended raindrop, something extraordinary happens. The raindrop acts like a tiny prism. When the light enters the water from the air, it changes speed. This change in speed causes the light to bend, a process known as refraction. But here's the crucial part. Not all colors bend by the same amount. The different colors that make up the white light, each with its own unique wavelength, bend at slightly different angles. Violet light, with the shortest wavelength, bends the most, while red light, with the longest wavelength, bends the least. This initial bending is the first step in separating the colors, like a musician tuning individual strings on an instrument. This splitting of light into its constituent colors is called dispersion. The journey isn't over yet. Once inside the raindrop, the no-separated colors travel to the back inner surface of the drop. Here, instead of passing through, a portion of the light is reflected. It bounces off the back of the raindrop, almost like a mirror, and is sent back towards the front. Think of it as a perfect, internal echo of light. As the reflected light travels back towards the front of the raindrop to exit, it has to pass from water back into the air once. Again, it refracts or bends. This second refraction spreads the colors out even further, fanning them into a distinct, brilliant spectrum. So, from a single ray of sunlight entering a single raindrop, we now have a tiny, personal rainbow exiting it. Direct. Red light emerges at an angle of about 42 degrees relative to the incoming sunlight, while the violet light emerges at about 40 degrees, with all the other colors fanning out in between. But a rainbow isn't made from just one raindrop. It's a collective phenomenon, a collaboration of millions. To see a rainbow, you must be standing with your back to the sun, looking towards the rain. Your eyes, the sun, and the center of the rainbow's arc must all be in a straight line. Each color you see in the rainbow comes from a different set of raindrops. All the raindrops that send red light to your eyes are located on a specific arc in the sky, at that perfect 42-degree angle from the line connecting the sun to your eye. The drops sending orange light are on a slightly lower arc. And so on, all the way down to the violet light at the 40-degree angle. Your brain then pieces together the light from all these countless droplets, perceiving them as a single, continuous, magnificent arc of color. This is why a rainbow is an optical illusion. It's not a physical object located at a specific place. So, you can never reach the end of a rainbow, because as you move, the set of raindrops creating the arc you see changes. The rainbow moves with you. It's a personal light show, created just for your eyes, from your unique perspective. Have you ever noticed a second, fainter rainbow outside the primary one? This is the secondary rainbow. It's formed by light that reflects not once, but twice, inside the raindrops before exiting. This double reflection reverses the order of the colors, so the secondary bow has red on the inside and violet on the outside. Because some light is lost with each reflection, this second rainbow is always dimmer than the first. The sky, between the two bows often appearing darker, is known as Alexander's band, named after the ancient philosopher who first described it. So, the next time the clouds part after a storm and the sun returns, take a moment. Turn your back to the sun and search the sky. When you see that breathtaking arc of color, you'll know you're witnessing an intricate dance of physics. You're seeing sunlight refracted, dispersed, and reflected through a curtain of millions of tiny prisms, all working in concert to create a fleeting moment of pure, natural wonder. It's a beautiful reminder that even after a storm, the world is filled with light and color, just waiting for the right moment to reveal itself. Thank you for joining me on this journey into the heart of a rainbow. We'll see you in the next one.